So yesterday we asked ourselves the question, how variable is the data? And really the only answer we could give was highly variable or high variability. There's kind of two ways you can say that. Or low variability. But if I asked you if one city was more variable than another, it was really, really hard to decide if one city would be more variable than the other as far as temperature goes. So today we're actually going to put a measure to this, which is called the mean absolute deviation. So it's a lot of words, but let's actually try to figure out what this is. So basically we have this right here, and we know that the mean of this data, it's told for city G, so we're not starting at A, we're starting at city G. We know the mean of this data. Let's go ahead and see if my camera can focus up a little bit here. We know the mean is 63, so it's about right here. So that is the center of the data, the mean. And I know that from reading through the problem. So we want to know the mean absolute deviation tells us, well, how far away on average is each point from that triangle? So again, how far away is each point? So if I consider the lowest temperature of 53, I can tell that it's 10 away from that. How did I do that? Well, I can just think about, well, 63 minus 53. That's how we got the difference of 10. Compared to this 57 degree temperature right here, it's only 6 away. So as we continue on, 60 is 3 degrees away from the mean of 63. This one is only 1 away. Well, this is also 3. We're going to keep going here. This one is 1 away. This one's 1 away. There's a lot of 64s. Those are only 1 degree away from the mean of 63. They're only 1 away. So that means they're 64 minus 63 is only 1. So let's keep going here. So 68, how far away is that from 63? Obviously 5 degrees, 5 degrees again, and then 7 degrees. So this is how far away each point is from the mean. So how far from the mean? So how far away are most numbers from the mean? That's what the mean absolute deviation is. How far are most of them? So to figure that out, I'm just going to find the total and divide it by the number of temperatures there are. And this time there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 total numbers, 12 total temperatures. Let's go ahead and add them up and figure out what the average distance away from the mean is. So I know 10 and 6 and 3 and 3 and 1 and 1 and 1 and 1 and 1 and 5 and 5 and 7. And so I get 44. But I want to find the average distance away, not just the distance away. So it would be 44 divided by 12. That will tell me the mean absolute deviation. That tells me most of these points are about 3.7, if I round that decimal, 3.7 degrees away from the mean. Most are about 3.7. That's the typical center. Let's double check just to make sure we added right. So I have 16, 6, 1, 2, 3, 4, 5. These are all worth 5. And then I have 1, 2, 3 5s, which is 15. And then add 7, that would be 22. So 22 and 6, that's 28. Let's just add 28 and 16 to make sure we're right. 44 is still correct. So here, the mean absolute deviation is 3.7 degrees. This means the temperatures in city G, the temps in city G, are usually about 3.7 degrees from, better make sure my answer is blocked off here, from the mean. So again, how did we figure that out? We found the mean absolute deviation. This represents the typical or normal distance each value is from the mean or from the center. So if we look back to our data, it says it's about 3.7 away. So if it was 63, that means most of the data is within 3 degrees this way and 3 degrees that way. So about from 59 to 66. And that makes sense because most of the points actually fall in that area. So what you're going to do now is you're going to find the mean absolute deviation for all the other cities. Now you might need to watch a video as you get started on A, and there might be a lot of pen the first time you try it. But then as you move on from city to city, you should gradually have less and less pen. Let me help you get started just on A. So the nice thing about A is they had no variation. But how far are these from the mean? The mean is 63 degrees, so it would be obviously 1 all the way down. And so that's a total of 12. And of course we know 12 divided by 12, because there's 12 values, would be 1. So in city A, most temperatures, and in fact all of them, most temperatures are 1 degree away from the mean. And so you'll continue working on this for each city. Each city you'll work on this for. So see if you can get started on B. The only hint I'll give you is 54 to 63. That's obviously 9 degrees away because I took 63 minus 54. And then here it'd be 9 again, 9 again. Then the only other hint I'll give you is down here on 72. Obviously it would be 9 degrees away. Again. So again, see what you can do finding the mean absolute deviation of each city.